Hi, welcome to Math After Hours with Miss Austin. I'm Miss Austin, a licensed math teacher here to help you with all of your math questions. Today I'm going to show you how to find the inverse of a 2x2 matrix. Why find the inverse, you may ask? Well, one of the main uses of the inverse is to help us solve a system of equations. So you may get to that later in your class, but right now we're just going to look at finding the inverse. So if a matrix has an inverse, it is called non-singular and invertible. If it does not have an inverse, it's called singular. And a matrix will be singular and have no inverse if the determinant of the matrix is 0. In a couple of my other videos, I taught you how to find the determinant of a matrix. And so that's the first thing you'd want to check, because if the determinant is 0, then it will not have an inverse. And then why go through the process? So with this matrix A that we are given, the first thing I want to do is quickly check the determinant. The determinant would be -4 times -2, which is 8, minus 6 times 1, which is 6. So the determinant is 2. Since the determinant is 2, we know we'll have an inverse, so we can go through this process. Okay, so what you'd want to do first is set this up with A on the left-hand side and the identity matrix on the right-hand side. An identity matrix has 1s along the diagonal and 0s everywhere else. So what we want to do is we want to turn this left-hand side into the identity. And then what will happen is we will end up with the inverse on the right-hand side. So we're going to do what's called row operations to turn this into the identity on the left-hand side. Okay, if we want to turn this into the identity matrix, the first thing I'm going to do is try to turn this right here into a 0. So we're going to have to do some combination of the two rows in order to make that be a 0. So what if I multiplied this whole row by 4 and this whole row by 6 and added them together? This is the same thing you would do if you were solving this using elimination with just equations, right? We multiply the two equations by something so that when we add them together, a variable cancels out. And it's the same idea when you're doing the row operations. So what I'm going to do is I'm going to write this as 6 times the first row plus 4 times the second row. And this is what we're going to use to change the second row specifically. So when I rewrite this matrix, the first row is going to stay the same. I'm only changing the second row. So this is going to stay -4, 1, 1, 0. If I multiply the first row by 6, I will get -24, 6, 6, 0. If I multiply the second row by 4, I'll get 24, -8, 0, and 4. And if we add these together, we get 0, -2, 6, and 4. And that right there is my new second row. So you'll notice we got the 0 that we wanted, so we're one step closer. So now we're going to go based on this matrix. What I'm going to do next is get my 1 right here. Any ideas as to what we could do to make this a 1? Well, what if we just divided that row by -2? What if I said I'm going to take row 2 and divide by -2, and that's going to become my new row 2. So what that means is that the first row is still going to stay the same. I'm not doing anything to change that, but everything on the second row will be divided by -2. So that's 0, 1, 6 divided by -2 is -3, 4 divided by -2 is -2. Okay. Now we're another step closer. We have the 0 and 1 that we want, because remember, the identity matrix looks like this for a 2 by 2, and this is what we want on the left-hand side. So we're kind of going in a counterclockwise direction. The next thing I want to do is this number right here. I want that to be a 0. So how could I use the second row to help me? What if we just do row 1 minus row 2? And I'm going to use that to change row 1 specifically. So we are now not changing row 2 anymore. So that will stay 0, 1, -3, and -2. And then for my new row 1, we're just going to do this row minus this row. So -4 minus 0 is -4. 1 minus 1 is 0. 1 minus a -3 is 4. And 0 minus a -2 is +2. Okay, and then we're super close. We just have one step left because we want this number right here to be a 1. So I'm going to do this the same way I got the 1 on the second row. Since that's a -4, I'm just going to take row 1 and divide by a -4 to change row 1. So -4 divided by -4 is 1. 0 divided by -4 is 0. 4 divided by -4 is -1. 2 divided by -4 is -1/2. And then the second row we didn't change. So you'll notice that now this left-hand side has turned into the identity matrix. So what we're left with on this right-hand side, this is the inverse. So we would label this as A inverse is the matrix -1, -1/2, -3, -2. And that is how you find the inverse of a 2 by 2 matrix. I hope you found that helpful. If you have any videos you would like me to make, please comment them below. Thank you for watching, and please like and subscribe.